So in the joint probability density function, the probability density function is nothing but the derivative of distribution function. So what is here we have considered? We have considered more than two random variables, yes or no? Because the term joint means what? So we are finding the probability distribution density function for more than two random variables. That is why we call it as joint probability density function. Okay. So in the case of one random variable, what is that? Probability density function is just derivative of distribution function. Since it is two random variables, now what is that we do? We do second derivative. We have to do derivative two times. Okay. So that is why fxy of x comma y is equal to dou square fxy of x comma y divided by dou x by dou y. Okay. So it is also called joint density function. Okay, here what is that we have to do? We have to do partial derivation by two terms, x and y, because we have it is function of both x and y, no? And that is why we have to do partial derivation by two functions. Okay, and this is called joint density function. Instead of calling it as joint probability density function, what we can call it as? We just call it as joint density function. Okay. For example, if you take for discrete case, so we know that in the probability distribution function, we will be having step function. Okay, step signal we are using, step function we are using in the formula. Whereas in the probability density function, what is that we do? We use impulse function. Okay, so here in the x value, in the case of discrete random variable, say the random variable x is having the elements x1, x2, x3, so on, xn, and y is having the elements y1, y2, so y3, so on, yn. Okay, and what is the joint density function here? It is same as our giant distribution function. Only in the case of step, what we'll be having impulse here. So fxy of x comma y will be equal to summation n is equal to 1 to n, summation m is equal to 1 to m, p of xn comma yn, del of x minus xn, del of y minus yn. Okay, in the distribution function we will be having step function, whereas in the density function we will be having impulse function. Okay, and what is this? This is the probability at the corresponding locations. Okay, now if you know the density function, how do you obtain distribution function, ma? So distribution function can be obtained by the integration. So we have to do integration with respect to both x and y. Okay, so if xy of x comma y is equal to integral minus infinity to x, my integral minus infinity to y, f xy of x comma y dx dy. Okay, we have to do integration two times. Okay, so that gives us what is that probability distribution function from the density function. Okay, so in this case what we did, we have taken only two random variables x and y. So what are the two random variables we have considered here? Only x and y. So for example, if you consider n random variables, what are those n random variables? X1, x2, x3, so on. Now elements of x1 will be small x1, elements of x2 will be small x2, like that. Okay, so in that case the probability distribution function and density functions are given like this. Okay, probability density function is given like this. So f x1, x2, x3, so on, xn. What are the elements of capital X1? Will be small x1, x2, x3, so on, xn. It is equal to how many times we have to differentiate now? Since it is function of n random variables, we have to differentiate n times. Okay, so it is dou n f x1, x2, x3, so on, xn. Okay, it is function of x1, x2, x3, so on, xn by dou x1, dou x2, dou x3, so on, dou xn. We have to do partial differentiation n times. Okay, so and how do we obtain the distribution function? This is the density function. No, this is the formula that gives us the density function. how do we obtain distribution function? The distribution function is nothing but the integral of density function. Now, how many integrations we have to consider? Since it is function of n random variables, we have to consider n integrations. Okay, so it is n integrations, and with respect to x1, x2, so on, xn. Okay, so this is the relation between probability joint probability density function and joint probability distribution function. Okay, now we'll discuss the properties of